Just a handful of harmless aluminum powder can actually set it on fire with your hands. But don't be deceived by his brilliant appearance, because once you reach the critical point of 2,500 degrees high temperature, so you have to lay on your knees and play Get Your Easy, which brings to mind images of matzo first. I can't forget the scene where Tong Lisheng's passport was too anxious. As the main structure in the combustion zone, its predecessor, stationary, was used to weld railroad tracks. It was first produced by German chemist Hans Goldsmith during the reduction reaction. Smith was originally designed to extract high-purity metals, especially but carbon in traditional metallurgy causes the reduction process to produce alloys. Therefore, Smith tried to use aluminum powder as a reducing agent to reduce oxides, and this was eventually developed into the thermite process. They also gave him a unique name. It's called the Goldsmith method, or the Goldsmith process. He patented it 2 years later, in 1895. It is necessary to know that aluminum can separate the oxygen in the metal oxide during the reduction process, releasing a lot of high temperature at the same time. It's 2,500 degrees centigrade. Therefore, the metal can be melted, except for aluminum mono system. There are also nonmetals such as silicon sheds that can be used to reduce, such as the meter method, silica thermal method, cover thermal method, and carbothermal method. But this is less known. Take meter for example. It can react at 4,500 degrees. Doses below 30 grams can only be administered standing 10 meters away, often used in high-powered incendiary bombs. So, let's have a look at a test screen. First, put 300 grams of copper oxide and aluminum powder into a dry pan. Then light each one together and stuff it into the pot. At this point, sparks more than a meter high can explode above. But that's less than half a kilogram. If you increase the dose and combine it with gunpowder, enough to melt through a crop tank. And this experiment is the process of obtaining metal elements from oxides by thermite reaction. Elements are pure substances composed of similar elements, such as gold, silver, copper, and iron. As long as it is not mixed with other elements, it can be called a metal element. But remember not to imitate the pain. Aluminum copper oxide will explode violently when ignited. Even in school chemistry classes can only be done with professional guidance. Look carefully to the left. This is just a normal low-dose burn picture. If you tuck it into a sealed case, the knock-on effect is really chilling. To say that this stuff made a first impression on a lot of people, that designation is low by leading the riding Zilong iron cable. Gun I had for inches of solid steel and destroyed that gun forever. In fact, the first batch of customers of thermite was Trunion Company. Intermediate shafts produced at the time were not as strong as cash. The problem of breaking and falling off occurs from time to time. The appearance of thermite just fills the gap in ocean maintenance. Of course, in this case, thermite cannot produce pure iron, and they add alloy powder to achieve steel welding. After all, pure iron loves rust and is of little use. Secondly, after the end of the Cold War, the big country takes the hot aluminum device to melt the tank barrel, and it was fantastic at the time. It only takes two people to blow an obsolete anti-aircraft gun. Evolved to today, the thermometer came to the battlefield in another way. The thermite formulation is not complicated or very rudimentary. The main body is composed of an oxide layer dropped by rolling steel coils, because they use a lot of water to cool them. During this period, oxide skin is formed, which will be collected by the factory and sold specially. It's a complete closed loop, not embarrassed at all. Then uniform particles of different sizes are separated by screening. You cannot increase a drop of water during the period. After separation, add aluminum powder to it in different proportions. This is the first generation of pure thermite. So, let's simulate a small device based on a projectile. Insert the eyeliner into the can. Stand 50 meters away and observe this rare sight. Compared to the previous round, this time the deterrent is even greater. There were obvious fights within a 20-meter radius. It's hard to imagine why this was used in the Russian-Ukrainian war. The most popular industrial thermite is welding rails, because there are often gaps in the joints during the laying process. At this time, the hot fleece wax should be poured into the steel film first. After forming a wax film, then fasten the positioning bracket and the protective outer frame together. Although from the appearance, this thing is a bit fooling. But after he was loaded onto the rails, the scientific evidence seems to have been further enhanced. Now, let's see what's in the barrel of the worker's kill. They are gray thermite and red peroxide cup. The particles are oxidized and turn off white, acts as igniter in the aluminum welding process. Simultaneous exothermic reaction, and then you stuff each dot into your head. In fact, this thing is not externally ignited with beautiful strips. The beauty is flammable, cheap, and large quantity. The key does not explode. If you are not afraid of the trouble, you can ignite it with ethyl deficiency or resistance heating. It's nothing more than the process of igniting aluminum powder. It's smoky outside, and inside it's not easy either. The travel point is approximately 2,500 degrees. The iron toll point is about 2,800 degrees. Once the boiling stops, the liquid will settle down. And liquid iron is more than twice as dense as liquid aluminum, so the iron will sink to the bottom. Aluminum floats above. The two don't interfere with each other. Iron is made of steel made of alloy powder. Any extra magazine will either fly to ashes or rise into the air during this 2,800-degree burn. This section of the rail is unfortunately completed. Come to World War I in 1915. The Germans started bombing Britain with zeppelins covered in thermite. People tried to put it out with water, but I didn't expect it to burn more and more violently. Thermite bombs are mainly aimed at people and armor. Once you come into contact, you will definitely burn a lot. Secondly, toxic gases can also cause respiratory organ failure. And what you see here are shells that contain thermite. The actual military incendiary bombs are roughly divided into three types. The first category is road-bed thermite weapons. With ultra-high temperature, can easily melt through armor. It is basically used in special space venues. The second is napalm, mainly used to burn cities and forests. For example, during the Vietnam War, the US military used aluminum powder as an accelerant, launched in many places in Vietnam. The third is zero egg, signed by the Geneva Conventions. In fact, the convention is only designed to bind the signatories. The countries that are going to use it, almost none of them have money. In fact, the convention refers to the agreement restricting attackers to non-military state animals. But how many non-military countries are there in the world now? So, instead of condemning mistakes, it's better to call for peace. Now, on to step 4. You've got eggshell form. Then carefully hoist and prepare to test the wall thickness and length of the pipe, and measured at 1,800 degrees just out of the oven. Although this method seems ancient, but it worked for semi-automated factories a few years ago. Then the eggshell is cooled and set to the machine tool for processing at equal points. Make sure it is a horizontal size. It's finished here on the bottom side. But the hardest part is not at the top. The factory policy is to heat the top to 1,500 degrees in 15 seconds, forming with the help of a vertebral press. Even if the offset is misplaced, it cannot be adjusted twice. We all know that steel structures often experience internal stress during the extrusion process, and brittle. In severe cases, deformation or even cracking may occur. And the same goes for eggshells. The stress generated in the metal is removed only after heat treatment. We want to make the steel structure more stable. Oil extraction plays a crucial role in this round. Oil green is the condition for small cleansing carbon steel to obtain hardness. Compared with shuqui, the cooling effect is milder. Shuqui cools down really fast. However, the tendency of hard cracking and deformation also gradually increases. This also caused most of the shells to be treated with oil extraction. The oil cannot be filled immediately after extraction. It has to go through an artificial processing. As we can see the picture, workers put shells into the equipment one by one, 3 times before and after to polish it out. Although thermite bombs can cause intense combustion, but he lacks the shock wave of an explosion like a warm duck egg. Secondly, the thermite reaction is rarely used in tactical attacks. It was used as a reserve warhead against railroad tracks, technical installations, etc. So you can hardly see that country mass-producing this stuff. Less effective than conventional weapons. On coal users, it takes a lot of time. The key is to use a large number of sites to isolate. At any time, the last touch of paint is sprayed into the surface and is formed.